Okay, Tier 1 people, I want to go over this process with you before you complete this week's assignment. Um, a lot of you are missing that you write what you know to begin with in the upper left, and that is over an empty box because it is assumed to be 1. Whatever these units are in the very next term must be what are written on the bottom so that your units can cancel. So and I'm trying to move you all into doing problems that are more like what you're going to see second semester. So I'm just adjusting my table there. So hopefully you can see, because you're in Tier 1, how this train track method, which is what you would use if you were writing it out, is much different. It is very similar, I should say, to the table that I used when I'm doing it on the computer. If you're doing fractions on the computer, you have to draw that line and it gets really hard to see. So that's why we use the table or this train track method. So your first problem, and you may not know these units yet, but I gave you the things that you needed to know. So we said that 1 mole has this many atoms. So how many moles would be needed to have this many atoms? So here you guys had to use your scientific notation, significant figures, but basically we knew that we were trying to find if we have 25 times 10 to the 23rd atoms, which I wrote in here. There shouldn't be a number 2 there. Let me make sure, get that out of there. So that's how much I knew. And then I know that 6.02 times 10 to the 23rd atoms. So I have to put that on the bottom so that those units cancel right away. I know that this is equal to 1 mole. So really, the times 10 to the 23rd atoms Na, or sodium, that's what cancels. And I'm left with 25, and if we bring up our calculator, I know I have 25, and it's divided by 6.02. That gives me 4.15. You guys know the math that you don't have to multiply it by 1, but you're not writing it out. And if you can't write it out on a simple one like this, you're not going to be able to write it out on a harder one. So I am really committed to y'all learning this process. All right, on the second one, let's look at it real quick. So density, and this one was hard because you had 2 units here. You had grams and liters. But the question was, let's take off our number there. Okay, so the question was, what would be the mass of this amount? So this is what we have, and we're trying to get to grams. So you start by putting in 375 milliliters helium. Okay, and from what I gave you here, I said, now some of you could have put in another term here, but you should all know that a liter is 1,000 milliliters. So I went right to 1,000 milliliters helium is this. Now I could have put in another term where I had 1,000 milliliters helium would go to 1 liter of He, and I could put in another term on my table where I had to put 1 liter He goes to 0.178 grams He. Okay, this is the same answer. I would get the same answer because 1, I'm multiplying by 1 and dividing by 1. So mathematically, that's no different. But here I have milliliters He. That cancels milliliters He. I have liters He. That cancels liters He. And I end with grams He, which is in fact what I'm trying to find. But again, some of you are missing what you write here, and that there is nothing written under it, and that the very next term must have this same units down here. You must write those same units down there to get them to cancel. All right, watch this video and then try this week's work.